2024 A-Level Combined Mathematics Paper 2 Part A question number 8. This question has to do with equilibrium of system of forces and friction. The question says, two particles A and B of masses m and 2m respectively are placed on a plane inclined an angle of pi/4 to the horizontal and are connected by a light inextensible string and are kept in equilibrium by a force P applied to the particle A as shown in the figure. Now looking at the figure, we can see we have our inclined plane and the particles A and B, and also we can see in between A and B we have a light inextensible string, and to the particle A we have applied a force P in the direction up the slope. Now after that, the question says the line of action of P and the string lie along the same line, which is the line of greatest slope of the plane. Now the reason they say this, of course, is so that we know that the force P, this string, and thus the tension in the string and the slope are all in the same exact direction, which is pi/4 relative to the horizontal above the horizontal. Now after that, the question says the particle A lies on the rough part of the plane and the particle B lies on the smooth part of the plane. Now the reason they say this is so that we know that in between A and the plane there's going to be a friction, but in between B and the plane there is no friction. Now after that, the question says the coefficient of friction between A and the plane is equal to half. So this means if you have normal direction, let's say R here, and a frictional force F here, the maximum value of F is equal to 1/2 times R, where mu is equal to 1/2, and therefore we get F equals mu R, becoming F equals 1/2 R. Now after that, given all of this information, they finally ask us to show that 2 times the modulus of root 2p minus 3mg is less than or equal to mg. Now, to start off this question, before we derive any equations, we need to mark all of the forces that are not marked in this diagram that are applied to the particle A and the particle B. Now considering that, at the start of the question they say the two particles A and B have masses of m and 2m, however in the diagram they have not marked the weights caused by those masses. So therefore, first off, let's mark the two masses and therefore the two weights of these particles. So the particle A has a mass of m and the particle B has a mass of 2m. Therefore, we will mark the downward force of particle A, the upper particle here, as mg and the lower particle here as 2mg. Now after this, since our string must be taut in between these two particles, there can be a force of T in between the two particles of tension. So therefore, I'll mark the tension up the slope on the particle B as T like this, and down the slope on the particle A as again T like this. Now after this, since the two particles A and B are lying on this inclined plane and they are not falling through the inclined plane, there must also be a normal reaction force acting from the plane onto these two particles A and B. So therefore, I'll mark that normal reaction like this on the particles A and B, and I'll mark the force on A as R sub A and the force on B as R sub B. Now in addition to these forces, there is one more thing we need to mark, and that is the friction in between the particle A and the plane. So I'll take that and I'll mark it over here. Now in this case, I have to mark the friction as either up the plane or down the plane. However, it should be noted that in this case, we could have the frictional force acting up the plane and still be in equilibrium, and we could also have the frictional force acting down the plane and still be in equilibrium. Both situations are possible. Due to this, I have to note that I don't exactly know whether the frictional force F is down the plane or up the plane. So due to that, if I assume that the frictional force is down the plane, then a positive value of F greater than 0 means our frictional force is actually acting down the plane. However, if we get F less than 0, it means our frictional force is acting up the plane. Now in this case, as we know that frictional force F is always less than or equal to mu R, we also know that our frictional force F in this case must be less than or equal to 1/2 R. However, since we don't know the direction, it could be either less than or equal to 1/2 R in the positive direction or less than or equal to 1/2 R in the negative direction. Now, considering that, we actually don't have any other forces to mark in this diagram, so now we can derive some equations. The first equation I'm going to make is coming from the fact that the frictional force F could be either up the slope or down the slope. Now if it's down the slope, it will be a positive value, and its value will be some value which is less than or equal to mu R, which is 1/2 r. So if f is greater than 0, this is the case. However, if f is less than 0, meaning it's up the slope, it will have a negative value, but negative f will be less than or equal to 1/2 r. And therefore, f will be greater than or equal to negative 1/2 r. Now, the combination of these two just means that the absolute value of f, the number over here, is definitely going to be less than or equal to 1/2 r. Combining these two, as we know, when we don't know the direction of the frictional force, we can say modulus of frictional force is less than or equal to mu r, and in this case, applying mu equals half, we can see that frictional force F modulus must be less than or equal to 1/2 Ra. Now, while this is a common thing to be known, I should specifically mention this, and that's what I did here, to derive it and show you exactly where it comes from. Now, from this, we can say our frictional force modulus F modulus must be less than or equal to 1/2 R, meaning that our frictional force can either be positive or negative, but its value must be somewhere in between negative 1/2 R and positive 1/2 R. And I'm going to call that equation number 1. Now, after this, the other equations that we derive in order to find this inequality right here have to all come from the condition that our system here is under equilibrium. So for this, I'm going to say for equilibrium, and I'm going to apply some conditions of equilibrium to the system of forces. Now, as we know, when any object is in equilibrium, the acceleration of that object in any particular direction is equal to 0. According to that, from F equals ma, the sum of forces in any given direction for a particular object or system must be equal to 0 if that object is in equilibrium. Now, for this, I'm going to consider two directions. I'm going to consider the direction up the slope, and I'm also going to consider the direction perpendicular to the slope like this. So I'm going to apply for equilibrium. I'm going to write in the direction up the slope like this, where the angle to the horizontal is pi by 4, and the direction perpendicular to the slope like this, where this angle is 90 degrees, and this direction is direction up the slope, and therefore this angle is pi by 4. So we are going to be considering equilibrium in this direction and this direction for all of these objects. Now, considering the objects, we can see we have two objects, object A and object B, and in addition to that, we could also consider the equilibrium of the system of objects A and B considered together. So therefore, we could either consider only for A, only for B, or both A and B. Now, considering our two directions, in the vertically upward direction like this, we can see for the particle A only, we have the force P, we also have the force T in the negative direction and the force F in the negative direction, but we also have a component of mg in that direction downward like this. Due to that, if we make an equation for A only, we will have four variables: P, T, F, and mg. Now in this case, I have the variable f in one of my previous equations. I'm going to consider that I know mg, and I'm going to consider that I want to find p. However, if I take for A only, I will also have the variable t in my equations. Similarly, if I consider only for B, then I'll have t and a component of this mg in this direction. Now in this case, I can see that I'm getting an extra variable t that I don't really want. However, if I consider A and B as a single object, then t here becomes an internal force since it's there, and its exact opposite direction force is also there, so it cancels out, leaving us with only P, F, this component of mg in this direction, and the component of 2mg in this direction. And since m is known, we can take both of those as being known, so therefore we have only three variables: P, F, and mg. So due to that, I'm going to consider equilibrium of the system in this direction. So instead of considering only A or only B separately, I'm going to consider for the system. Now when we do this, we can see the total internal forces get cancelled, and all we have left is external forces. And considering the external forces in the upward direction, we have force of P. So we have P in the upward direction. Now considering the other forces of F, the component of mg downward, the component of 2mg downward, are all in the negative direction. So therefore, if we take left hand side upward direction and right hand side downward direction, we have P equals, and on the other side, we have F, the component of this mg, and the component of this 2mg. Now according to that, we can see, since the angle here is pi by 4, the angle here would also be pi by 4, and since the total angle is 90 or pi by 2, the other angle here is also pi by 4. Now considering that, we can see if we draw the triangle needed, this component here is going to be the cosine of this angle, which is pi by 4, and similarly for this angle this is also pi by 4, and therefore the side that we want is cosine of pi by 4 once again, and therefore for both of these forces the component we want is cosine pi by 4. So therefore the component of these two forces going in the downward direction like this is going to be plus mg cosine pi by 4 and another plus 2mg cosine pi by 4. Now simplifying this down, we can see we get P equal F plus, and if I factor out the mg's here, we have mg and 2mg, which is 3mg, times cosine of pi by 4, which is 1 over root 2, and therefore we have P equal F plus 3mg over root 2. This is going to be equation number 2. Now after that, if we consider the perpendicular direction, we could once again consider for only particle A, only for particle B, or for both particles A and B. Now considering only particle A, we can see in this direction we wouldn't have the force P or the force F, but we'd have the force RA and mg's component in this direction. Similarly, for this force we can see we would have RB and we would have the component of mg in this direction. Now if we consider both A and B, we would have RA, RB and both components of mg in this direction and 2mg in this direction. Now considering that, in our previous equations we can see we have F, RA and P and mg. We do not have RB. Due to this, finding RB would not be useful for what we already have. However, finding RA from this equation right here would be useful. So therefore, finding for RB or the entire system is not useful, but finding for only RA is useful. So therefore, I will try to find for the particle A to get the value of RA. So if I apply 4A, I can see in the upward direction I have only the RA force, but in the downward direction I have the component of mg in this direction. Now since the other component was mg cosine pi by 4, this component must be mg sine pi by 4 rather. So therefore what I need here is mg sine pi by 4 in the downward direction like that. So therefore I have in the upward direction RA equals, in the opposite direction, the downward direction, I have mg sine pi by 4. So I have mg sine pi by 4, which is also equal to 1 over root 2, and therefore I get RA equals mg over root 2, and this is equation number 3. Now considering what we have so far, we have F, RA, P and mg in our equations. Now if we consider mg to be known, then we have 3 unknowns, and they are F, RA and P. So therefore we could substitute and solve for at least one of them. So that's exactly what we're going to do. We're going to try to solve for one of them, and if we do that, we can see we will end up with something that looks like this. We can see by intuition, if we substitute into F here, we will have the modulus on one side, we'll have the inequality, and therefore we will probably get what we want by substituting into this equation right here. Rather this equation right here, in order to get the value of P, and then we'll get 2 times modulus of root 2p minus 3mg less than or equal to mg. So for this, I'm going to substitute equation number 2 and equation number 3 into equation number 1. So doing so, I can see from 1, 2 and 3, if I substitute into 1 the values from 2 and 3, from 2 I can see I get P minus 3mg over root 2 equals F. So therefore I get for modulus of F, modulus of P minus 3mg divided by root 2 less than or equal to 1/2 RA, and for RA we get mg over root 2. So therefore I get 1/2 mg over root 2. Now, to simplify this down and get what we want up here, I have to multiply everything by 2 root 2. We can see if we do so, then on the inside we can have a root 2 times p on here, and on the outside we can have a 2. So therefore, I'm going to multiply everything by 2 root 2, the denominator here. Doing so, I can see since 2 root 2 is positive, on the right hand side I get the same exact inequality and mg, but on the left hand side I get 2 root 2 times this whole thing, and if I keep the 2 on the outside I have 2 times the modulus, and on the inside I have everything multiplied by root 2, which means I have root 2 times p, root 2p minus 3 mg divided by root 2 times root 2, which is going to be equal to 3 mg. So therefore I get 2 times modulus of root 2 minus 3 mg less than or equal to mg. And this is exactly the inequality that they want us to find at the start. So with that, we are actually done with this question. Now finally, let's go up and discuss the marks order for this question. So at the start of the question, interestingly, they actually give you 5 marks for marking out all of the forces that act on the particles A and B. So for marking RA, RB, the mg, 2mg, the tension force and the frictional force, here you get a total of 5 marks. Now after that, from the fact that we don't really know whether the friction is downward or upward, but at maximum can be equal to mu r, and writing that means that the frictional force's modulus is less than or equal to 1/2 Ra, which is mu r, you get 5 marks. Now after that, for the other two equations, when you apply for equilibrium in the upward direction up the slope for the whole entire system and get this equation, you get 5 marks. And then when you apply for the direction perpendicular slope for only particle A and get this equation, you get another 5 marks. So for these two, you get another 5 marks. And after that, the final 5 marks is obtained when you combine equation number 1, equation number 2 and equation number 3 to get rid of all of the variables except for the variable p, and then get this exact equation, or rather inequality, which is what we have given at the start of the question. For getting that using the substitution, you get a final 5 marks. And that is all we have for this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.